Here we have a characters problem in related rates. Okay, let's go to the information. At noon, ship A and ship B leave from the same point. Ship A is sailing east at 35 km per hour and ship B is sailing north at 25 km per hour. How fast is the distance between the ships increasing at 4 p.m.? Okay, let me mark this is a point at where both the ships leave. So the ship A is sailing towards the direction east. Let me mark it over here. And ship B is sailing towards north. Okay, so we know that this is the direction of east and this is the direction of north. So here we have ship A and here we have ship B. Okay, the distance covered by the ship from the point of start to somewhere else is as x. I assume the distance covered by the ship as the variable. So because this distance is getting changed, that is increasing because ship A keeps moving towards east. And the distance covered by the ship B can be assumed as a variable y because this is also this distance also is getting changed. That means increasing. So we assign a variable for this one. And now let me assume the distance between the two ships A and B as the variable, again the variable z, because this distance is also getting changed, that is increasing. Okay, now I have assigned the variables x, y, z. X represents the distance covered by the ship A from the starting point, and y represents the distance covered by the B from the same starting point, and z is the distance between the two ships. Okay, now let's go to the information. Ship A is sailing east at 35 km per hour. That is, every hour, the distance covered by the ship A is getting increased by 35. So we can write this one as derivative, because whenever a quantity is getting changed, we can express a change as a derivative. And also, it's sailing means it's increasing. The distance covered with the ship A is increasing. So that means its x is getting changed by 35 kilometers per hour. So here the distance is getting changed with respect to time. So we have to write this derivative with respect to time. That is dx over dt. That means the distance covered by the ship x is getting changed with respect to time. It is given by 35 km per hour. And also dy over dt. This represents a change in y. That is how the distance covered by the ship B is getting changed with respect to time. That is given by 25 km per hour. So how fast the distance between the ships is increasing? That is, they are asking us to find the rate of change of z with respect to time. We have to find dz over dt. So using this information, dx over dt equals to 35, dy over dt is equal to 25. So we have to find dz over dt. That is the rate of change of the distance between the two ships. We have expressed that one also as a derivative. Okay, now what we have to do is we have to link the three variables x, y, and z, so that we'll be able to use the information we have over here. So clearly, it's a right triangle because our right angle over here. Because ship B is sailing towards north, so we have a vertical line over here, and ship A is sailing towards east. We have an horizontal line over here. It's a right triangle. In this right triangle, we can use Pythagorean theorem. By using Pythagorean theorem, so what do we get? So Pythagorean theorem says sum of the squares of two legs of a right triangle equals to square of the hypotenuse. Clearly, z represents the hypotenuse because that's opposite right angle. So now let me write the equation using Pythagorean theorem. That is x square positive y square equals to z square. Okay, now if I want to use that value 35 for dx over dt, 25 for dy over dt, and also if I want to find the value of dz over dt, I clearly have to find derivative over here in this equation with respect to time. Okay, now let's find derivative in this equation with respect to time. So if I find derivative of this x square, I'm getting 2x. So because I just used the power rule, I got the exponent in front of the variable and subtracted 1 from the exponent. So far, I have done derivative only for the exponent 2. By chain rule, I have to do further derivative for the base x with respect to time. Then I'm getting dx over dt. The same thing, when I do for y square, I'm getting 2y times dy over dt. And on the right side, when I do the same thing for z square, I'm getting 2z times dz over dt. So here everything is a multiple of 2. So whether we can divide the whole equation by 2 to simplify. So let me divide each term of this equation by 2. This 2 will cancel. Here the 2 will cancel. Here also the same thing, 2 will cancel. So I'm getting the resulting equation is x times dx over dt positive y times dy over dt equals to z times dz over dt. Okay, here our aim is to find the value of dz over dt. That is how fast the distance between the ship is increasing. So, but if I want to get dz over dt, I have to plug in the values for the other quantities. I know that dx over dt is 35, dy over dt is 25. But what are the values for x, y, and z? So the question is ask us to find dz over dt. That is distance, how fast the distance between the ships is increasing at 4 p.m. And also, the two ships A and B leave from the same point. That is, this is a point over here. Let's say this is a point O origin. Just for an example. Okay, both the ships, the ship A and ship B, both the ships leave from the same point at noon. At noon means what? 12 p.m. So let me write the stuff over here. And so they are asked us to find how far the distance between the ships is increasing at 4 p.m. 4 p.m. means at 4 p.m. So what is the distance covered by the ship A? That is given by X. So from 12 p.m. to 4 p.m., what is the time duration? It's clearly 4 hours. So in 1 hour, ship A covers a distance of 35 kilometers because according to the information, 35 kilometers per hour, ship A is sailing eastward. In 1 hour, it covers 35 kilometers per hour. So from 12 p.m. to 4 p.m., that is from noon to 4 p.m., how many kilometers of distance covered by ship A? Then I have to find that, I have to multiply this 35 by 4 because this is the distance covered in 1 hour. So to find the distance covered in 4 hours, that is from 12 to 4 p.m., I have to multiply this 4. Then in that case, we get X equals to 140 because 35 times 4. And so in 1 hour, the distance covered by the ship B is 25 kilometers according to the question, 25 kilometers per hour. So from 12 p.m. to 4 p.m., that is in 4 hours, how many, what is the distance covered by ship B? For that, we have to multiply this 25 by 4. So then Y is equal to 25 times 4 is 100. So at 4 p.m., the value of Y is 100. Okay, now we got the value of X at 4 p.m. and value of Y at 4 p.m. At the same time, we have to get the value of Z at 4 p.m. So how do we have to do that? So for that, we have to use the same equation, the one we got by using Pythagoras theorem to get the value of Z. So let me take this equation over here. So in this equation, I'm going to plug in X is equal to 140, then it will become 140 square. And for Y, I have to plug in 100, it will become 100 square equals to Z square. So when I square this 140, I'm getting 19,600. So for 100 square, I'm getting 10,000 equals to Z square. Then I'm getting 29,600 equals to Z square. So my aim is to get the value of Z at 4 p.m. For that, I have to take a square root on both sides because to get rid of the square over here. So when you take square root on both sides, so this square and square root will cancel out. And now I have to simplify the square root of 29,600. For that, so 29,600 can be written as 100 times 296 equals to just Z, we have Z on the right side. So we know that square root of 100 is just 10. So we get 10 times square root of 296 equals to Z. Further, this square root of 296, I mean this 296 can be resolved into its prime factors. So when I do so, I'm getting 2 times 37. When I resolve this 296 into prime factors, you can use it with L division. So for every two same numbers multiplied inside the square root, one number will come out. For these two twos, 1, 2 will come out. And inside the square root, we have 2 times 37 equals to Z. It's not 2 point, it's 2 times. So 10 times 2 is 20 times square root of 2 times 37 is 74 equals to Z. Okay, now I got the value of Z at 4 p.m. That is 20 times square root of 74. Okay, now I have the values for all the quantities over here for X, dx of dt, Y, dy of dt, Z, everything. Now let's plug in the values over here. For X at 4 p.m. they are asked us to find how fast the distance between the ships is increasing at 4 p.m. At 4 p.m. We got the value of X, that is the distance covered by the ship A is 140. We can plug in 140 for this X, and dx of dt represents how the distance covered by the ship A is getting changed. That is how the rate of change of X. Already we know that it's 35 from the question, so we can plug in 35 for this one. For Y at 4 p.m. we have 100, dy of dt is 25 equals to, for Z we have 20 times square root of 74 times dz over dt. Let's do all the possible simplification over here. So when I multiply this 140 by 35, I am getting 4,900 positive 2,500. So equals to 20 times square root of 74 times dz over dt. So when I add these two values, I am getting 7,400 equals to 20 times square root of 74 times dz over dt. Okay, now let me erase the stuff over here. Okay, now let me continue the problem over here. That is, let me write the same equation. 7,400 equals to 20 times square root of 74 times dz over dt. So since our aim is to solve for dz over dt, so we have to get up this value which is multiplied by dz over dt. So for that, I divide both sides by 20 times square root of 74. By 20 times square root of 74. So this one will cancel out. And so we have 7,400 by 20 times square root of 74 equals to dz over dt on the right side. Okay, here in denominator we have an irrational number, square root of 74. So to rationalize the denominator, I have to multiply both numerator and denominator by square root of 74. So when I do so, I'm getting 7,400 times square root of 74 divided by, so 20 times, when I multiply the square root of 74 and square root of 74, I'm just getting 74 equals to dz over dt. Let me write it over here. So this 74 goes into 74 one time, 74 goes into 7,400. 100 times, because 74 goes into 74 one times and we have two zeros over here. 20 goes into 21 times and 20 goes into 105 times. So I'm getting 5 times square root of 74 equals to dz over dt, or we can write this one as dz or dt is equal to 5 times square root of 74. So that is the z represents the distance between the two ships, and also we got a positive value for dz over dt. So whenever the derivative equals a positive value, we have to understand, so the quantity over here is increasing. In case if I'm getting negative value over here, it's decreasing, but here we got the value of the derivative, that is dz over dt. It's a positive value, that is 5 times square root of 74. Since it's a positive value, it's increasing. That is z. Z means the distance between the two ships is increasing. So how do we have to write units for this one? Already we know that both the distance x and y, distance covered by ship A and distance covered by ship B are given in kilometers, and the time is given in hours in both the here. When I look at the rate of change of distance by ship A, rate of change of distance covered by ship B. So for z we can take the distance kilometer. For this t we have to take r. So we have to write the unit for this one is kilometer. And since we have t in denominator we have to write per hour. So the distance between the ships is increasing at a rate of 5 times square root of 75 kilometer per hour at 4 p.m.